We just got done talking about the system versus the surroundings. And when we think about the system versus the surroundings, in this little particular part of the unit, we're going to look at endothermic process and exothermic process. And when we look at endothermic versus exothermic, we're going to think about it in terms of phase changes. We're going to think about it in terms of chemical reactions and then also solution making. When you make a solution, the little ions break apart. When they break apart, they have an energy transfer and then they go back together. So you have different things that you're going to think about in terms of endothermic or is it exothermic. So when you do that, you really have to think about what is the system and what are my surroundings and where is that heat transferring from and to. So if you have something that is endothermic, that means that heat is entering into it. Endothermic, heat is entering into it. So in this case, I've got a person sitting by a campfire. And with the person sitting by the campfire, you look at this and you say fire, heat, that's hot, exothermic, but that's not actually the case in this one. So we are looking at, in this case, the person that is sitting by the fire. And if the person is the system, we want to know, is that person endothermic or exothermic? So in this case, we have the heat on the outside. That heat is traveling into the person overall. He is stealing the heat from the fire. So the person is the system. The person is endothermic. So when you are looking at your system versus your surrounding, figure out what you are studying. That's going to be the biggest key to try to figure out if something is endothermic or exothermic. So in this case, I've got a lady who is running. With this person who is running, if she is the system, we want to know, is she endothermic or exothermic? In this case, she is exothermic. Her body is creating heat, her body's creating sweat. That heat helps to evaporate away the water that comes from the sweat, and then as that evaporates, it actually pulls the heat away from the body and it takes it into the air. So when you are looking at this, she is exothermic because heat is exiting from her body itself. So she is exothermic. The opposite of that, if the air was the system, we would have to flip that around and we'd have to think about it in a different way. So really try to figure out what is your system and what is your surroundings if you are asked what is something that is endothermic versus exothermic. So with the endothermic versus exothermic, when heat is absorbed or heat is lost in the reaction overall, that's called a change in enthalpy. Enthalpy is a fancy way of saying heat, basically, but it's the heat content in a system. So when we are studying the heat lost or the heat gained in a system, it's called the change in enthalpy. Change in, remember, is a triangle. That's what we had delta T earlier in this unit and last unit. So when we look at the change in enthalpy, the delta, you're going to have what's called a delta H. Delta H is change in heat. I know that we used Q before. Q and delta H are very closely related to one another. We'll kind of get into that in a little bit. But for right now, just know that delta H and Q can be used interchangeably in reactions as we're looking at this. But your delta H is just the heat transfer that's happening in the system. So here I put down that Q is actually the same as delta H, just to simplify things. As we get into AP Chem, you'll get a little bit better understanding there, but for right now, it's the same. Again, we're trying to simplify everything. So when you have delta H being positive, that means that you have your endothermic reactions. So you are absorbing heat. The heat is entering into the system. So when your value for delta H, or Q, is positive, that means that you have an endothermic reaction happening, or an endothermic change happening for that matter. When we write out chemical equations, you can actually put the word heat or energy or the delta H value, so it'll be a number in kilojoules. You can actually write that on the reactant side, and I'll show you what I mean by that in a minute. So if delta H is positive, or if you have heat written on the reactant side, or energy, because heat is a form of energy, it is endothermic. And that is because heat is entering into the system, which means that the amount of heat is going up. It's gaining heat. It seems a little backwards because, like exothermic feels hot, so people think, oh, that needs to be positive, though that's actually negative because the system is losing heat and transferring to you. So with endothermic, it's going to feel cold to you because it is actually absorbing your heat and transferring it into that environment. When your delta H value is negative, that means that it is exothermic for the reason that I just said. We can actually write the word heat or energy or the amount of kilojoules of heat as a product because heat is exiting out of that reaction overall. Endothermic, it enters in. Exothermic, it exits out. So as that heat exits the system, it loses that energy that's there, and as it's losing energy, it's exothermic. Heat enters, endothermic, heat exits, exothermic. So in these scenarios, just very briefly, you're going to see different things like on a test where you're going to have to figure out if this is endothermic or exothermic. So if we only look at the first line up here, it says aluminum hydrochloric acid, we are making hydrogen gas and aluminum chloride. My delta H value is negative 234 kilojoules. In this case, it gives me my delta H value overall for this reaction. With this delta H value, that is the amount of heat that is lost or gained in the reaction overall, this has a negative value. If we have a negative value there for delta H, that means that it is exothermic. Heat is exiting away. So I would label this first one as exothermic. The next one, we have nitrogen reacting with fluorine. We are making nitrogen trifluoride, and we have energy written on the product side. So it just says energy. You can also just write the word heat. You can also put a value for your kilojoules there. This one is written on the product side, so it's exiting out of the reaction. If it exits out of the reaction, this is an example of an exothermic reaction. This one down here, we have the delta H value. Instead of giving it off to the side, it's written on the reactant side. So when it's written on the reactant side, you can think about it as heat entering into the reaction with the reactants. So if it's entering into the reaction with the reactants, that is called an endothermic reaction. If it was written over here, it would be exothermic, but it's written on the reactant side. And then the last one down here, your ammonia with your sulfuric acid. When they're reacting together, we have heat written on the product side. So instead of writing the word energy, they wrote the word heat. You can also give the kilojoules. So in this case, it says heat right here. That heat is a product, so it is exiting out of that reaction. So when it exits out of that reaction, this is an exothermic. So for right now, all you're going to do is you're going to use the values that are there to figure out if something is endothermic or exothermic the way that it is written. You also have phase changes that you're going to look at with these, where it'll say, hey, we've got this phase change of evaporation. Is evaporation endothermic or exothermic? Well, in this case, all of them, you have heat entering into it. For example, melting, you have an ice cube. That ice cube is in the solid state. The energy needs to enter into the ice cube in order for the little particles to move faster to turn it into a liquid. So melting, sublimation, and evaporation are all examples of endothermic reactions. They start at a colder temperature, they have to end at a higher temperature. Heat needs to enter into it. So in all of these cases, they are all going to gain energy. Energy starts low, ends high. So that means that freezing, deposition, and condensation are all exothermic. With these, it's the opposite effect, that your heat needs to exit from them. So when you go through freezing, you have a liquid, and as you have that liquid, the little particles are moving fast. Well, you have to cool them down in order to turn into a solid. So the heat needs to leave the system and go to the surroundings. So freezing is exothermic, and that one always kind of trips people out. Deposition and condensation are all the same way. In all of these cases, the heat exits from the system, so it's going to start at a higher temperature and at a lower temperature. They are all going to feel colder. Get colder, feel colder. So this happens in the winter time with oranges. If we have a big freeze, kind of like, this past winter, they will actually, like a farmer, will take the citrus crops and they spray it down with water. And as they spray it down with water, the news people always get this wrong. They always say, oh, they're spraying it down with water to freeze the oranges. That's not actually the case because they're trying to protect the oranges from freezing. So what they actually do here is they spray it down with water. When they spray it down with water, the heat from the water leaves the water and goes into the orange. So when the heat leaves the water and goes into the orange, the internal temperature of the orange goes up, and it protects the inside of the orange from freezing. The outside is frozen, but the inside isn't, because all that energy is transferring into the orange itself. And if you freeze an orange, it's actually no good anymore, because all those little juice pockets all pop, and then it's just like mush on the inside if you get a frozen orange. So with your crops, they use this to their advantage with your heat transfer. So that's actually as far as we needed to get today in the video. If you guys have any questions, definitely ask. Otherwise, I hope you have a great day.